I'm a geneticist by training, and as much as I would like to say genes don't play a role, because when we talk about, for instance, chronic diseases, we know that, for instance, cancer may be 5-10% related to genetics. But when it comes to overweight and obesity, it's actually the role that genes play. It's enormous if you think about it. And how is it that we know how much is it genes or how much is environment in any given disease? And right now we are focusing on overweight and obesity. It usually comes from twin studies. So what we do is we look at twins, and could be, preferably, it would be identical twins that were raised separately. And we have many of those. And if you see that identical twins that were raised in different countries, they'll have weights that are very similar, then the likelihood, and eating different diets, so the likelihood that genetics plays a big role, it's something that we can estimate, right? So, and there are other studies that are done with animals, right, that also allow us to infer how much or what is the percentage of genes that are influencing a certain disease. And when it comes to overweight and obesity, we know it's a big range, but it can be between 47% up to 93%, depending on the gene. And on average, then, we believe is between 70 and 80%. So, which is enormous than you think. So if genes are regulating 70 to 80% on average of our risk, then we would only have control over 20 to 30%. But here's the interesting thing. Cancer, it's 10% genetics, 90% environment. So we know we have a lot of control over it, right? With obesity, 70% genes. But here's the thing, the amount of genes related to obesity is very high. So up until now, we know there's maybe 120 different genes or mutations that are associated with overweight or obesity. So 120 genes across all of our chromosomes, all our 23 pairs of chromosomes. So that's a lot of genes, right? And some of them are what we call monogenic genes, so it's monogenic obesity, and some of them are polygenic genes or obesity genes. So what it means is if it's a monogenic obesity gene, just the presence of this gene, not the gene, but the mutation in the gene, is enough for you to present the disease, okay? So we're all going to have all the genes. It's whether or not we have a certain mutation or not, right? But the majority of obesity that we are dealing now, this obesity epidemic that we are dealing now is related to what we call polygenic obesity. It's a sum of the effect of multiple genes that will cause the phenotype being overweight or obesity, right? So I'm going to give you examples. And sometimes there are genes that can do both. It can be monogenic obesity or related to polygenic obesity. So an example of a monogenic obesity gene would be the leptin receptor gene. So we all have the gene and its function and it's great. But if we have a specific mutation in this receptor, then the brain doesn't see leptin. So we're producing leptin, but we don't have the receptor. It's not receiving the message. And then we're going to have obesity as a phenotype. What happens with monogenic obesity genes usually is that the person is going to have obesity very early in life. Why? Because it's very genetically driven. So there's no way around. So obesity, overweight and obesity that we see, which is afflicting most of Americans and most people around the world, like almost 2 billion people in the world are considered to be overweight. So that's polygenic. So it's like an array of genes all acting together. And one of the ones that is a major contributor gene for polygenic obesity is called FTO, or fat mass and obesity genes. And there's a third gene And we're going to be talking about FTO a little more, so I hope, right, over the next 45 minutes, an hour or so.